So till last time we have covered this optical fiber system, okay, in proper depth. Now today we have to cover this sensors part, okay. So of course it is very simple. Whatever the sensors you may have known already now, but this time we need to make sensors with the help of fiber optic cables, okay. And this system or this setup we are saying as a FOS in general, fiber optic sensors. But before moving to the sensors part, okay, in proper depth, I just want to confirm or to ask few things from your side. Okay, so whenever you hear this word sensors, okay, to what exactly uh, things came into your mind? So what things you can imagine when you hear this word sensors? Anyone can please reply.
Robots.
Robots, okay.
So the lift doors, automatic lift doors, and the doors in malls and all.
Okay, automatic door. Okay, fine. Sensors are there in that automatic door. Okay,
Driverless car.
driverless cars. Okay, so these are you can say that these are the applications of sensors. Okay, somewhere in automatic door opening, somewhere in the automatic driving of car, something. So what about the actual sensor? Suppose if let's take it very easy. If I say you need to prepare a sensor, okay, you need to create a sensor, let's say for a particular device. So then what are the things you will keep in mind while designing the sensor? Yes, yes, I see into the chat box. People are replying. That's great. Proximity sensor, and then also these are the applications or the part of sensor. But basic thing, what you required, okay, anything that can detect the presence of light. Okay, that is one answer. Apart from that, any other which you may think of?
What will be the use?
Use, okay, okay. See, keep it very simple. Okay, अगर आपको वो आइडिया, अगर आपको समझ में आ गया कि सेंसर्स का मेन वर्किंग क्या है, सेंसर्स का मेन फीचर क्या है, देन दिस पर्टिकुलर चैप्टर इज क्लियर टू यू, वेरी सिंपल. सो अगर मैं आपको इसलिए बोल रहा हूँ, if you want to create a sensor, okay, or if you want to prepare a sensor, then what are the features you are looking for in your sensor in general? Okay, forget about any particular device, forget about this fiber optic thing, only sensors you talk about. So what are the things or the parameters or the characteristics your sensors must have?
What
Sir, we
change
must
will
decide that what change in surrounding it will sense.
Okay,
yes,
basically
yes.
sensitivity, right? कि वो
Yes,
sense
sir.
कर पाए. Perfect.
Also frequency, sir. Frequency.
Frequency, okay. Reaction time, someone has written that also. Reaction time, that is perfect. Ability to sense, okay. So yes, all these things are really important for any sensor, not only this fiber optic, but any sensors you can find out in your surroundings. So now let me come to the next so that we'll see. So you see the introduction part again little bit. So let me annotate also. So optical fibers, you see, have a major role not only in this communication. This already we have seen already. This optical fiber cables we are using for sending the signal from one side to the another side. Okay, but you see, it is also used in the development of different type of sensors. Okay, so there is more field not only to this communication part, but apart from that we can use in sensors also. And second is, you see, these optical fiber sensors, okay, it successfully meets the requirement. What are the requirements? High sensitivity, okay, as someone has said already. And second is this quick response or the reaction time, basically in sensing different objects or variables. So these are the two phenomena or two things you have to keep in mind while designing any kind of sensors. Okay, so I am generalizing right now. Don't look at for this fiber optic sensors, but in general, you look at any sensor. These are the things you have to keep in mind while designing such setup. Okay, so optical fiber cables are fulfilling this requirement. Okay, that is why we are going to use optical fiber sensors. Now let me come to the next. Here it is again, what you can measure with this. So they have described over here, you see. So this can sense, okay, optical fiber sensing devices. Okay, one can measure or monitor different physical and chemical parameters. I will come to know what are the different physical and chemical parameters. Okay, so in terms of again principal parameter that describes the light beam, because fiber optic cables are carrying the light signal only, light beam. So that is why light related all such physical chemical properties which you may think of, we need to find or detect with the help of these sensors, optical fiber sensors. So you see light related all such parameters or phenomena you see again in the next. So these principal parameters include the intensity of light, phase, okay, polarization of light, or wavelength of light also. So all such principal parameters are related with this light beam. Okay, so we need to see the changes in these properties, okay, with the help of optical fiber sensors. So that's how these sensors are useful. Now coming to this sensors actually, okay, how to define? Suppose if someone say you need to define the sensor, okay, in some words, in some one or two line. So you see this line. So it's a device, okay, that can measure the physical quantity, and it can convert that physical quantity, okay, into a signal readable by the observer or the instrument. So sensor is basically working on two front. Okay, one is it is sensing the quantity, okay, and second it is converting that signal in the readable format, either by the human being or maybe by the instrument itself. So for example, you say already you have done so many practicals. So you take the example of, let's say, temperature. Okay, so suppose if you want to measure the temperature of a particular device or object, so there is a thermometer which we are using in our laboratory. So, okay, so now you see that thermometer is also a sensor. How it is working? So first, that probe, the point, okay, you have to put in contact with the object, which is hot object. Okay, so basically it is sensing that hot nature of that material, how much hot it is, okay, how much the temperature it is, okay, then it is sensing, and then it is converting into the readable format. You see, if suppose you consider a thermometer, okay, it is sensing fine, but it doesn't have any scale, okay, so then it may be very difficult to know how much amount of temperature varies. Okay, 5 डिग्री से टेम्परेचर इंक्रीज हुआ, 10 डिग्री से इंक्रीज हुआ, 20 डिग्री से इंक्रीज हुआ और समथिंग. सो इट मे बी वेरी डिफिकल्ट if that scale is not there. Are you getting the point? So there are two main things you have to keep in mind. Sensing is one thing, but whatever the thing you are going to sense, you need to convert into the output, and that output too readable by either human being or maybe by the machine itself. Okay, so many a times in case of thermometer, we are manually taking the readings by looking at the thermometer, but many a times there are some automatic scale also. Okay, if you go towards uh, high end temperature devices, okay, so you see that signal is going to be read by automatic. As example, right now I'm doing one experiment. Okay, so in that experiment I have to put my samples which is in powder form, and I have kept it in a furnace. So that setup is currently going on. Just before the lecture I started this setup, and I set the temperature around 500 degree. Okay, so what happens is the temperature, I already, the rods are there by which the temperature is getting on. Okay, temperature is getting increased, but you see on the digital count I can see the number. On the digital screen I can see the count. Okay, this much is the temperature right now of that furnace. So what happens is that the device is sensing the temperature, okay, and then it converts the signal into the readable format. वो automatically वो machine ने काम कर दिया. It displays the number in digital format. कितना temperature हुआ, I can check it now. Okay, so मुझे केवल read ही करना है, उसको पढ़ नहीं है. वो ऑटोमेटिक कन्वर्ट कर दिया. बट इन केस ऑफ थर्मोमीटर आपको देखना है कि वो स्केल कैसे आपको रीड करते आता है कि नहीं आता है. सो दैट्स हाउ it is very important that signal has to be readable either by the human being or by the instrument itself. So I hope now it is clear. Sensor is working on two front. First, it is sensing that quantity. Temperature is one such quantity. Similarly, you can find more such quantity of similar pattern, and then it has to convert into a proper signal. So that is the main object of any sensor device. Feel free to ask if you have any doubt anywhere. Okay, and then you come down next, capability. This is also important because many a times I have given I have suggested you many times, I have given few lectures on this also, that whatever the systems you are going to design in future, or maybe in the current semester or maybe in the upcoming semester, okay, so you need to look it for the capabilities which it can hold. Okay, so again you see in this capabilities, suppose if you are planning to design such kind of sensors, not optical fiber but any kind of sensors if you have in mind, and if you are going to plan it, then what are the things you need to mind. Okay, but here right now I will discuss in the optical fiber case, but the same you can easily modify it as per the requirement of another sensor. So you see the capabilities, okay, for this sensor. So optical fibers offer very low loss, okay, to the signal propagating through it. So we can use this method for remote sensing also. So there are various applications where we required high precision data, okay, and that part can be done by this optical fiber cables, because it can sense it and it can transmit the data up to a longer distance also. That's why this can be useful for remote sensing applications. There are so many. You just type on the Google and find out what are the different remote sensing applications. Okay, remote means far distance available जो होगा, और मतलब काफी दूरी पे अगर कोई ऑब्जेक्ट रखा है, उससे रिलेटेड अगर आपको कोई चीज फाइंड आउट करनी है, दैट विल बी कंसिडर्ड एज ए रिमोट सेंसिंग. वो बट एप्लीकेशंस में भी डिफरेंट. ओके, सो सपोज यू टेक लेट्स से चंद्रयान, ओके, और एनी डिवाइस विच इज फार अवे फ्रॉम अस, ओके, वो स्पेस में है कहीं पर, और आपको उससे रिलेटेड कुछ पैरामीटर्स कंट्रोल करना है या कुछ डेटा फेच करना है, सो दैट कैन बी डन. So that devices, that applications we are saying is the remote sensing. So control mechanism here on the earth, we can control it, but actual setup is somewhere else. Okay, so somewhat similar. You can find out more about this also, because one complete syllabus you may find out on the remote sensing technique as well as on the applications part. But this is the general idea I'm providing to you. Okay, it may be plus minus also a little bit, but this is how they are doing. Control system is somewhere other end, and your actual device is somewhere else. Okay, and they are measuring the signal, they are transmitting the signal. So there may be multiple remote sensing devices you can come across if you search it properly. Second, in this case we place the control. You see, again same thing I'm coming. In this case we place the control electronics for sources and detectors far away from the sensor head. You see, so your sensor may be at one end, okay, but your control device may be at the other end. So you see, that's why it is very important. Another one is high flexibility. Okay, so as you know that optical fibers cables are highly flexible compared to any other metal cable or something. So flexibility is there, and as a point sensor they can be used to sense normally inaccessible regions without perturbing the transmitted signals. So if you remember, I may have told you in the case of optical fiber thing, that it is used in sewerage line also, or the places where the human cannot reach, or even if reach is possible, but it may be very disturbing, okay, to go through manually and check out surroundings things. So that is why these optical fiber sensors can be useful in such areas also, where the regions is not properly accessible, okay, and without disturbing anything, without perturbing your signals, etc. So these are the things that can be useful in such scenario. Another is, see, various other advantage you see, like chemical inertness. That means no such effect of chemical, because the glass, okay, so little bit inertness, one can say chemical inertness. You see, intrinsically safe. Why we are saying intrinsically safe? Because losses are very less, as well as the moment if you break it out, everything will be destroyed. Okay, so basically it's a safe. आपका data lose होने का chance नहीं है. Security will be there in this case. And even though you see, it can be used in this explosive environment also. Okay, carefully आप कर सकते हो, because it can sustain up to certain degree temperature also, so that may be useful, and potentially resistant to nuclear or ionizing radiations. But this last sentence will depend, of course, on so many parameters. Normal optical fiber cannot sustain, but as I said, there are variety of optical fibers are available, okay, and scientists are working on such kind of things more and more, so that they can be resistant to this nuclear war event or maybe some ionizing radiations part, so they can sustain in such a particular event also. So let me come to the next. So that were the capabilities optical fiber sensors may have. Okay, so same thing when you design some sensors. Okay, so you have to also keep in mind such kind of parameters. Okay, it is not like exactly all such will fit over here, but some of the parameters may be required. And coming to these types of fibers, fiber optical system, FOS. So basically there are two types we can classify. One is intrinsic sensors and second is extrinsic. Again, from the name itself it may be very clear. Okay, intrinsic means sensors के अंदर होने वाला जो changes होगा, that we are saying is the intrinsic. and extrinsic means sensors ke bahar. So whatever the things going to be changed outside the sensors, that we are knowing as the extrinsic sensors. Okay, we'll discuss one more time in detail. So you see the intrinsic sensors. Let me annotate one more time. One by one we are discussing both the types. So first, in this sensor you see the physical parameters. Okay, just 1 minute, let me move it. Yeah, so you see the physical parameters or maybe the effect जो भी आपको sense करना है, which you want to sense it, and modulates the transmission properties of the sensing fiber. So ये सब कुछ fiber के अंदर ही है. Okay, inside that sensor, inside that system, these changes are possible. Okay, so what are the parameters you can change it? You see the physical properties of guided light, like intensity you can change it, phase, polarization, all such things are going to be modulated. Change in the sense, technically if I use the word, that is modulated. So these things can be modulated inside this system of sensors. Okay, that's why we are saying is the intrinsic sensor. Now coming to the next,
Sir, does it
extrinsic.
mean that it changes the properties of the fiber itself, sir?
Yes. See, आपको वो mechanism use करना है by which you can change the property of light. Okay? तो वो सिस्टम आपको फाइबर के अंदर ही यूज करना है, वो सेटअप आपको फाइबर के अंदर ही करना है, ताकि आपका जो भी चेंजेस करना है आपको सिग्नल में, यू कैन प्ले विद दैट. We'll come to that. We have all such applications or also we'll discuss during that time. Okay? So don't worry. And now you see in the case of extrinsic fibers or sensors, okay, so you see in this setup is very self-explanatory. You can see that. Okay, so this is your output fiber cable, I mean input fiber cable, this is your output fiber cable. Okay, and in between there is a setup. Okay, that means outside the fiber we are doing the changes with this, you see. So here is a modulator. Okay, fiber is fiber, you see fiber cables, input fiber or output fiber, it is just working like a carrier only, which is carrying the signal. But actually things are happening outside this optical fiber, which you can see in this particular setup. Okay, again I'm repeating, you see again the modulation take place outside the fiber. In this case the role of fiber will be just a carrier to transport the light signal to and from the sensor head. Okay, but वो सारी activity जो भी changes वाली है, that is outside the fiber we are doing. So that is why we are saying is the extrinsic sensor. So if again let me clear it out, if this changing part is going to happen inside the optical fiber, we are saying as the intrinsic. Outside the optical fiber we are saying as the extrinsic optical fiber system. Okay, or sensors basically. So you come down again, here it is. So based on this, as I said, changes is nothing but basically you can modulate your signal, okay, either inside or outside. So based on this, these are the 5 different categories people have classified. Okay, one is intensity modulated, which is important. Okay, and second is the phase modulated. So these two we are going to cover in proper depth. Okay, others are there, but still the use of these three, it may not be I mean this may not be covered in your syllabus. Okay, because that requires advanced level devices, and advanced level devices, then again first you need to go through the devices properly, and then only you will come to know how these techniques are going to be useful for that. But since these two can be in our daily life, normally we are using in our surroundings, so that is why our preference will be on this intensity and phase related sensors. Of course all these three are there, but they are used in some other devices which may not be useful in our daily life. Okay, not normally we are going to use in daily. So that is why these are with the technical applications. We'll see also a little bit about this कि कहाँ पे use करते हैं. So you see intensity modulated fiber optic sensors as well as phase modulated fiber optic sensors. So use, as I said, the first 2 or 3 are going to be most commonly used, okay, in a wide range of applications. Coming to the next, here is the first example. Okay, so you see the device name, fiber optic temperature sensors. Okay, that means sensor cable, fiber optic cables you have to use to measure the temperature of a device. And for this you see which kind of modulation we are going to use, that is intensity modulated. Okay, that means again it is clear, intensity modulated, that means intensity you have to modulate so that you can change or you can note down the changes happening in the temperature of a device. Okay, so here it is, you see this particular part, so light source. Okay, this setup will be like this light source, this optical fiber, this semiconductor chip. Okay, even though it seems very large, but it is not the case. Just for reference or just for seeing purpose, we kept it large, but otherwise very small semiconductor chip material. And then these optical fiber cables are connected with that. Okay, so now I will give this task to you people to find out, go through more about the theory part and find out this intensity modulated sensors are of intrinsic type or extrinsic type. Okay, so you go through that, you take your time, maybe by coming to the next lecture, okay, you must come up with some idea or the answer, which kind of sensors. So whatever the sensors I'm going to discuss today, I will give you the task that you have to find out whether it's an intrinsic case or it is the case of extrinsic. Okay, so you see the setup, light source you have, that means for input signal, light detector, that means for output signal. Okay, you have this medium, that is optical fiber, by which your signal is going to be transmitted from one device to the another side, and in between you are keeping this semiconductor in contact with this optical fiber cable. And you see this semiconductor chip I have connected with this temperature source. So this block diagram is basically indicating this temperature source, and that is connected to the semiconductor chip. Okay, now look at what we are doing is, let's go to this slowly so that you can understand again one more time. So this temperature sensor diagram is there. Okay, fiber is connected, you see, same thing, with thin semiconductor layer kept in a sandwich manner, okay, between this light source and the LED laser. And photo detector, of course these photo detectors are of so many types, PIN, APD. So forget about this at this moment, because these are the generalized term, but you simply consider as a photo detector, because there are multiple photo detectors are there. Okay, and the chip is kept in contact with the temperature source, as I said, you can see with the diagram. So diagrams are very important. Whatever the sensors you are going to use, if you make proper diagram, then everything you can write based on that. Okay, here it is, same thing we are doing right now. Now coming to the next, how this setup is working. So you look at this principal part. Okay, let me go through it again carefully. So it measures the temperature of the system. You see, again, the things is same because we are using the temperature sensors. So that is of course very clear. We need to measure the temperature, we need to note down, and we need to see the changes actually, because sensor will work only when you see the changes in the temperature. Okay, so it measures the temperature of a system, okay, by the modulation of light intensity from a target or a temperature sensing material. So what happens is, you need to note down your temperature after the light intensity changes. So before the temperature, or before the temperature source, what is the light intensity, and after putting the temperature source, what is the light intensity. There is a change, of course, because you have connected to the temperature source. So you can see what is the changes are there in my light intensity, whether it's decreased, increased, or it is constant. So that changes you can note it down. We'll see that how to change that or how to come out with the conclusion part. So it's clear, you have to modulate the light intensity, and that is why we are saying is intensity based, intensity modulated sensor. So you have to modulate the intensity of light, okay, and that light is coming from a target or a source, whatever you say, or somewhere temperature sensing material also we are saying. And it requires, this is important, it requires a temperature sensing material. Okay, because if temperature sensing material is not there, then you cannot measure the temperature, you cannot sense the temperature, right? So you require a device. Just 1 minute. So you require a device, and see, these materials are basically either silicon. Okay, these are the temperature sensing material, either silicon or somewhere a combination of these two, gallium arsenide. So this is also a very famous material. You people are, if interested, then you can search about more of this. What is gallium arsenide? What is the use of this gallium arsenide? Okay, in different applications. So I suggest, if you have free time, you must go through this part at least. Okay, and you require C. So it requires a temperature sensing material and a multi-mode fiber. So that is the requirement for performing this task. And you see, the temperature sensing material will change its optical properties. That material, whatever you have placed, this gallium arsenide, etc. So they are going to change these properties, okay, of light. Either it can absorb it, okay, it can transmit it, or it can reflect also. So whatever the material you have, sensing material, okay, that can absorb some light. If that is absorbing the light, then again you will see the change in the intensity. Okay, again how much amount of light is going to be absorbed, how much amount of light is it is going to transmit, okay, or it is going to reflect. So based on that you will see the change in your intensity. Are you getting the idea? You are giving a light signal, okay, and then you put a temperature sensing material. Now it depends on the temperature sensing material, it can absorb it, it can transmit it, or it can reflect it also. Okay, so based on that you may see the change in the light intensity at the other end. Okay, so one can, by looking to the change, okay, one can calibrate their scale and come out with the answer that yes, this is the intensity which is going to be changed through the system. Okay, we'll come to that also. I will describe you one more time. Okay, and you see क्या क्या change कर सकता है, optical properties like this, as well as band gap is also an optical properties. So that can be changes with the temperature. Okay, you people are knowing that the band gap of material can be changed with the help of temperature. कैसे करता है all such things, that is a separate story again. Now look at here how this process is work actually. So this light intensity, okay, during the transmission get modulated by this source, okay, during the transmission through the chip. As I said, the chip we have connected over here, okay, with the temperature source. So with the help of that you can change or you can modulate your light intensity while transmitting itself. Okay, and here come the answer. The original wavelength of light which you incident on the semiconductor shift towards the higher wavelength with the increase in temperatures. So can you see that how it is working? Just because of that semiconductor source, that material is in contact, because you see these are only the temperature sensing material, or semiconductor only, nothing else. Silicon is also semiconductor, gallium arsenide is also a semiconductor only. Okay, so because if you increase the temperature of these semiconductor sources, okay, so the light intensity of the original source is going to be changed. Okay, whichever light you are going to incident, their intensity, their wavelength is going to be changed. So you see wavelength is moving towards higher wavelength with the increase of temperature. Okay, they have given this also, that I is directly proportional to the energy, and you know that in energy and this wavelength, they are going to inversely proportional to each other. Okay, but don't go with that, it's very simple. When you change the temperature of the sensing devices, okay, so their wavelength moves to the higher wavelength because their energy is going to be changed. And you see this as it is used, okay, it shows better change in the wavelength. So wavelength में आपका change होगा because of this. Accuracy, you see this device can be useful from 10 degree to 300 degree. Okay, sometimes people are claiming minus 10 to 300 degree also. So again, this task I will leave it to you people to find out what may be the exact number, whether it's plus 10 or minus 10 to 300 degrees. So this is the range in which this can provide you the accurate result. And of course, you see it's very simple and cheap compared to any other devices, because you only required the setup and a temperature source and a semiconductor. So that's how you can easily prepare this kind of sensors. Okay, so I hope this idea is clear. But remember one thing, whatever the device you may have, okay, that may have some advantage as well as some disadvantage also. Disadvantage, or let's say pro and cons, basically one can say कि किसी चीज में वो device आपका it's very good, but in some particular thing it may not be working properly. Okay, there may be some flaws in that particular device. So let's come to that part. Okay, and more such details, whatever the doubt you people may have, we all can discuss maybe at the completing this topic. Okay, so don't worry about that. You just note it down all such queries and we'll discuss surely. So come to this part I will talk about, because this is related to this sensor only. So you see the changes basically. So what happens is, many a times that system, you know the process, you have seen already the working also, how the system works. Okay, but sometimes it may give you the false result also. Okay, it may give you the false result also. How it can give you the false result? So then you see this particular modulation, okay, intensity modulation can take place through the light interruption, okay, due to the displacement of one fiber relative to the another, or misalignment of one fiber to the other end. So this, to understand this particular line, again coming back to the previous slide where you see कि your light is traveling, you are transmitting from one side to the another side. Okay, you are changing the intensity, okay, with the help of the temperature source. Okay, their wavelength is going to be changed. Now suppose for a moment if you see that optical fiber cables are not connected properly. Okay, they are connected with slightly slanted angle, not exactly peak to peak, but slightly with some angle it is connected. Okay, displacement basically one can say. So you see displacement or something. So because of that also you may see the changes in the light intensity. Are you getting the idea? Our purpose is that through such system or sensors we need to note down the sensing material, we need to note down the sensing quantity. Okay, we need to see the changes in the light intensity. Okay, but if that is the actual case, but what about if your instrument itself or your fiber optic cable itself is not connected properly, or it is some misalignment in the fiber optic cable with respect to each other, then also because of this misalignment or displacement, then also one can see the change in the intensity. So basically this will give you the false result, where you don't know whether it is corresponding to the actual result, or it may be corresponding.
सर आपकी आवाज नहीं आ रही है.
Sir, your voice is not coming. Sir,
सर हेलो सर.
Sir,
sir, hello.
हेलो सर.
Sir. Hello.
सर.
sir,
Sir,
Sir. Hello. Hello.
They can't hear you, sir.
Yeah, do we have to leave?
हेलो सर. हेलो.
Okay, now it is clear. As I
Yes,
said again that internet,
Yes, sir. Yes, sir.
yes, internet got disconnected. So because of that. Anyway, so let me start again with the slide. Okay, so don't worry about this part. I will start again. So what I was talking about, see many a times you are going to use the device, but important thing again, it is not using the device, it is like how you are going to use your device. Okay, and what are the problems you may face in your device and how to rectify that. So as I was talking about, if your setup is working properly, working fine, that means you are changing or you are seeing the changes corresponding to the actual result. Okay, but what happens many a times, just 1 minute, yeah. So what happens many a times, yes, any doubt? Okay, so what happens many a times when you do this, sometimes you are setting everything, and by chance or by mistake, if your optical fiber cables are not connected properly, there is some misalignment or there may be some displacement of one particular fiber, then it may be difficult. So what happens in that case? In that case also, because of this misalignment, you will see the result. That means the change in the intensity you can notice at the other end, but that is due to this kind of misalignment also. So one has to be very sure whether the changes in the light intensity is corresponding to your original temperature source, or it may be because of this misalignment problem. Okay, because in both the case you will see the readings, you will see the changes in the intensity of light. Okay, so that's why while performing this kind of particular sensor or using the sensors, one has to be very careful. Otherwise you may think of कि हो सकता है कि भाई मेरे टेम्परेचर के कारण मेरा रीडिंग आ रहा है, but it is maybe because of this misalignment also. Okay, so that's why it's important. And here I talked about this misalignment part. So this misalignment, you see, it can be of three types. So if you are interested, you can go through more axial or longitudinal misalignment, transverse, angular misalignment. Well, from the name, it is clear, but still, if you want more details, okay, how to rectify that, then you can find out more. You use these keywords, and you will come to know about various things. And you see this, out of these three, the transverse misalignment is more sensitive. Okay, so basically, you need to avoid this one. Fine. So just try out and possible way. So then you have to remove this transverse misalignment if any. Okay, because this is very sensitive and easily you can see the change in the reading. Now coming to the next line. So this sensitivity part of these optical fiber sensors can be enhanced. Okay, by cleaving. Cleaving is a technique. Okay, so you just again find out more and polishing. So cutting करना है कैसे क्लिप मतलब कट कैसे करना है आपको उसको पॉलिश कैसे करना है ऑप्टिकल फाइबर को ग्राइंड कैसे करना है so that is very important. So polishing the two ends and you have to connect at a slant angle and keeping the slant face of the two fibers sufficiently close. That means let me clear this particular last point. Okay, annotate one more time. So suppose if you want to connect these two fibers, suppose this fiber एक फाइबर केबल मेरे पास ये है, this piece I am having. Second fiber cable, again I have this one. Okay, this is the second fiber cable. So now you see these are connected face to face. Okay, so in this particular case there may be a chance कि थोड़ा सा misalignment हो जाए या थोड़ा सा displacement हो जाए. Okay, but consider in another case जिसमें अगर मैं ये fibers को rather than in this direct way face to face, if I use in this order. Okay, can you see this particular way? This way we are saying is a slanted angle. That means you make some degree, okay, and you connect the optical fiber cables in the slanted angle. So by this way you see the chances of losing the light signal is very less compared to this one, and that is why people are preferring this one. And if you go for this kind of setup, then you have to follow this cleaving process, and then you have to polish the surface also. Then only you can try to connect in this order. Okay, but remember this is the very perfect case in which the chances of losing the light signal is very less if you keep arranging this pattern. Okay, but if you connect in this setup, so chances are there thoda bhi misalignment hua, thoda bhi fiber bend hua, okay, your signal may be lost. But more such details I have just given you the idea. Okay, more such you can find out how cleaving can be done, how polishing can be done, and how we can join these fibers at slanted angle. Okay, a slanted face.